Welcome back, everyone. So my name is Sabrina Kleisel. I'm an associate working with the Carbon Trust, and I'll be your host for today's case studies. So yesterday we have already heard from 7 IEEA-supported companies. If you have missed any of that session or want to revisit any of the specific videos, we have recorded the entire session and will make these available to you after the end of today's event. So we will hear now directly from 7 of our IEA-supported companies. And our first case study of the day is by Surface Generation. They have demonstrated their low thermal mass technology for polymer manufacturing by eliminating conventional steam heating within compression molding.
Hi everyone, my name's Andrew Sharp from Surface Generation. I'd just like to spend a few minutes talking to you about our project, which was called CREATE, which was carbon reducing advanced thermal engineering. Our partner in this was Tyflex, who are based down in Liskeard in Cornwall. So what brought this project about was that we realized a substantial proportion of industry still relies on old energy intensive processes. And because they're old energy intensive, the margins are low and there's not quite the money there to invest. So what we were trying to do with this project was develop an affordable heating and cooling system to significantly reduce energy and reduce cycle times as well. So if we can get energy down, we can get cycle times up, we can hopefully improve margins and competitiveness, and also at the same time get the CO2 down. So Surface Generation, we're the lead company. We were established in 2002, and we were developing a unique technology called production to functional specification, which is called PTFS basically. And Tyflex, a long-standing partner down in Liskeard in Cornwall, they were manufacturers of cork and rubber bonded materials. So probably when you step on a tube train, if you look at the floor, those guys probably made it. So the technology is all about really zoned heating and cooling. What we were trying to do was take the mass of the tool out. So what we'd look at is a tool face, which is extremely lightweight, which takes very little energy to heat and cool. And what we're trying to do is just heat the tool face rather than the whole of the tool. So traditionally, you might heat a tool that's 50 kilograms in weight up to perhaps 130, 140 degrees C, which can take a lot of energy and a lot of time. But if you actually only heat the tool face, which weighs perhaps 2.5, 3 kilos, then the energy used to heat that up to 130, 140 is much less. And also the energy is far more directed. It's directed at the tool face rather than losses through pipes and things. So the impact of the project was actually pretty impressive. We were very pleased. In the proposal, we estimated about 82% energy saving. And in the end, we actually achieved 87.3% energy saving, and which equated to just over 43 tons of CO2. And we were saving almost 250,000 kilowatts of energy. And this was done because we lightweighted everything. We took a lot of the weight of the tool out. We directed the energy at the tool face. And we were able to then use a new control system, which enabled us to reduce that cost and reduce the cost of the complete installation. Originally, our system was based on aerospace technology and was very expensive for just molding industry. But on this project, as some of the benefits, we managed to reduce the cost of our system considerably to bring it more into line and more economic for the general molding industry. Tyflex originally used steam heating to heat their tooling, which was very, very inefficient and used a lot of energy. And as you can see, as I've just said, we saved 87% just using electrical energy over their traditional steam energy. And of course, today with the price of gas as it's going up, which they use gas to actually create the steam, this is extremely beneficial to them potentially in the future. So we talking to Steve Ward, who is the R&D manager down at Tyflex. The lower energy consumption that we've shown them is obviously a significant benefit for them. If we can reduce their reliance on steam generation for heating and cooling, that'll allow them to grow a more sustainable business. It will allow them to have a more competitive business as well, which will allow them to obviously then hopefully have more money there to invest in further technology developments to reduce CO2 levels. So what are we going to do next beyond the IEEA? Well, we're going to harden the tooling. So there's a few areas that we know we can just make it slightly better. And we're going to exploit the developed technology in the general molding sector. So other companies like Tyflex who do general molding, compression molding potentially, then that's something that I'm sure we can help out. And furthermore, what we'd really like to do is, as well as the general molding sector, is look at other sectors which are very energy intensive, such as advanced composites. For instance, autoclaves use extreme amounts of energy. If we can find a way of eliminating the autoclave or reducing its usage by using our technology, then that'd be a great thing to do. So that's really it. Thanks for listening. That's a very brief summary of our project. It's been very successful. And if you need to contact us, then these are our contact details. But I'm sure if you contact the Carbon Trust, they'll be able to put you in touch with us. So thank you very much.
Thanks, Andrew. And yeah, if you want to get in touch with any of our technology developers or partner organizations, very welcome to reach out to us and we can put you in touch. Next one is G2O Water Technologies. So Craig Clement will introduce their advanced nanopulse filtration system using graphene oxide coated membranes.
Hello, I'm Craig Clements, the Chief Operating Officer at G2O Water Technologies. I'm here to take you through our IEEA project, Industrial Laundry Wastewater Recycling. We've been running this project with our partner Johnson Service Group, our industrial partner. And Johnson's are the UK market leader in washing hotel linen and kitchenware across the UK. The idea of the project is to recycle the water from their washing machines, but put the hot, clean water back into the washing cycle, saving obviously not just the water, but energy as well. Industrial laundry wastewater is a complex waste stream. It has large variations in pH and temperature, and hence, this technology is not currently deployed across the UK. Our industrial demonstrator project has been at the Johnson's operation in Shaftesbury in Dorset, and the project started in September 2019 and is due to finish at the end of this month, November 21. Well, how does the technology work? Well, G2O Water Technologies, we're a business that develops advanced membrane technology. Our first generation of products are membrane coatings. And in this project, we have applied our graphene oxide coating to a commercially available ceramic membrane, as shown on the diagram here. And we apply the coating to the inside of the ceramic tubes. And this helps with anti-fouling performance of the membrane. It increases the lifetime of the membrane and reduces the time between cleans of the membrane. The membrane is installed into the industrial laundry recycling system, as shown in the middle here. The system is provided by our partners Hydrosist, and this system has 18 membranes. You can see here the 3 loops, and each loop contains 6 membranes. The industrial laundry recycling system is obviously cleaning the water. On the right hand side you can see a rather dirty waste stream that is cleaned on the right hand side with the use of the system. Here we have a picture of Mike Range, the engineering manager at the Shaftesbury operation. Mike's comment, we've tried a number of systems over a number of years to deal with this waste stream. This new system is working very well for us, and we've got lots of positive results. Mike has got experience of the industry, having tried a number of different recycling systems, many of which have not worked, and therefore, the Johnson's team are really pleased that we've been able to pull together here a successful system. What's been the impact of our project? What savings have we demonstrated? Well, the savings amount to more than £100,000 for the Shaftesbury operation. The largest financial saving is in the water. We've reduced the use of water by 60% by recycling, and that amounts to 24,000 cubic meters across a year. We've saved over a gigawatt hour of energy, and that's based on a calculation of the washer efficiency around about 80%. We intend to further validate these gas savings with a 3-month test period with Johnson's from December to February 22. This saves around about 200 tons of carbon per annum. And then in terms of what can we do with this, where can we take it? Well, in the UK, there are around about 110 sites, that industrial laundry sites that could take this technology. And globally, there are around about 4,500 sites. So there's a significant opportunity to roll this out. And to finish with a comment from Alexandra Brennan, the head of sustainability at Johnson's. The Johnson's team know that their operation is water intensive and energy intensive. And they're really excited by the results here, that we've been able to demonstrate a technology that really works for them. Johnson's as a business have over 40 sites, and they're really looking at this as being a potential game changer for their business. Thank you.
We will hear now from Peter, the Paper Industry Technical Association. Barry Reid will talk about their project implemented at Smurfit Kappa, including the demonstration of a novel simulation-aided advanced process control software at the paper mill.
Good morning. I've been asked to come along today and talk to you about our IEEA project, the simulation-aided control of the drying process in the paper industry, or as we prefer to call it, twins. The choice of this photograph isn't totally arbitrary, as half of our project team actually originate from Austria. Unfortunately, we all tend to look a little bit more like Danny DeVito than we do Arnold Schwarzenegger, so I apologize for that. The concept of twinning is not entirely new. The highest profile and one of the earliest examples of digital twinning was the Apollo 13 moon mission. At around about 2:07 Universal Coordinated Time on the 13th of April 1970, when the Apollo 13 moon mission was at over a 250,000 miles from Earth, a dramatic explosion tore a hole in the side of the service module, leaving the spacecraft in distress. Obviously, NASA put in place emergency procedures to bring the air to protect the crew, but then they were faced with the challenge of flying an untested spacecraft in a completely new configuration around the moon and back to Earth. In order to achieve that, they made use of the training simulators that had been developed to train the astronauts back on Earth. They converted the training simulators into models controlled by the computers, and were able to model the performance of the spacecraft and the systems on board. It's important to make a few points about digital twinning. As I say, it's not new. The term was first termed in 2002. Historically, it's been used for relatively slow moving environments. But the first use of the term is in a NASA roadmap report. NASA are quite active in this. As the performance of computers has increased, so the capabilities of digital twins have increased alongside them. A quick word about models. We're all used to using conventional models of systems. They tend to be data-driven and they are highly accurate within the bounds of an existing process, and they're used all the while. These can be extended to predictive models that can extrapolate forward with reasonable accuracy changes in that system, and those are quite widely used as well. Mathematical models are different. Mathematical models go back to basic physical principles and mathematical equations to calculate variables either within or outside the existing boundaries of an operation. And this enables us to move into new areas outside of the knowledge that already exists within a system. To carry the space analogy forward, a mathematical model allows us to go where no man has gone before. Let me briefly introduce you to the product team, the partners. Obviously, the main one is Smurfit Kappa, who are the paper mill who allowed us to use their facilities. I'll tell you a little bit more about them shortly. CF Proxim is the key technology developer. They're based in Austria. Automation X is a process control specialist company based in Austria who work very closely with CF Proxim, and Perceptive Engineering is a similar process control company in the UK who work very closely with the Smurfit Kappa mill. And of course, propping it all up at the bottom, you've got the Paper Industry Technical Association, where I'm from, who are a membership association serving the pulp, paper and board industry globally. As I said, a little bit more about the Smurfit Kappa mill. It's a 150-year-old site, which formerly had two older paper machines producing 230,000 tons of fine paper. Around about 2014, that was converted to packaging grades, and they then subsequently invested in a new CHP plant to reduce carbon emissions. They're capable of making 260,000 tons of packaging paper, but with the drive towards lightweighting, that figure's been reduced to more like 230,000 tons because paper is produced in square meters rather than by weight. This is the basic paper making process that the mill operates. We pulp paper up, we squirt it onto a wire like a sieve to let the water drain out. We then put it through two presses, very large mangles, which press water out of it. And then we take it into the drying section where we use heated metal rollers to drive the remaining moisture off. Now, the Smurfit Kappa system is slightly different to that, in as much as they have two sets of dryers because they add chemicals in between, but they're both basically the same. Steam and dry air are put into the system, and warm, moist exhaust air is extracted to atmosphere. This is very fortunate because it means we can do work on one section and test out ideas that we're going to use on the other section, which is what we're doing at the present moment in time. Okay, so the achievements to date, it took a lot longer to complete than anticipated due to COVID-19, and nearly 600 days elapsed from our first meeting on site to our second meeting on site. But we got there, and as you can see from the graph at the bottom of the page, the results of the simulation and the measured results are exceedingly good. The mill were very impressed by the correlation between the two. The twin has already identified certain issues on the paper machine that people didn't know were there before, like a valve actuator being connected inappropriately. And it's also being used by the mill to explore what-if scenarios without putting production at risk. The mill are able to move outside the box while still making paper in the normal manner. So, as I said before, we started on the after dryers, and the immediate results are that the exhaust fan speed has been reduced by up to 35%. So that's 35% less hot air being exhausted to atmosphere. We've reduced the supply air temperature from 105 to 80 degrees C with no loss of drying performance on the paper machine. On the after dryers alone, we're estimating that there's a steam saving of 2 to 2.5%, which is, in paper making terms, is quite significant. We also have a range of advisory functions. When the model sees performance moving in a particular direction, he is able to step in and make changes to the system. And we can also measure performance in key areas where it might not be possible to make any measurements. And this is a comment taken from the Operational Excellence Leader at the mill, a gentleman we've been working with very closely. So what next? We intend to extend the control of the pre-dry section, which could result in another 2 to 3% steam saving. We can also look at the heat recovery system in the condensate to save a further 1%. The technology, well, there are 43 paper mills in the UK producing 3.6 million tonnes of paper. This could be replicated at the majority of those. And there are 894 pulp and paper mills in Europe, and this would be applicable to those mills as well. So the market potential is huge. Thank you for listening to what I've got to say, and I hope you find it interesting. And to continue the space theme, live long and prosper.
Thank you, Barry. Now we're moving on to the Mineral Products Association. So if you have joined our panel discussion earlier today, you will have heard Richard Lees already mentioning their IEEA project. So MPA have developed and tested low carbon multi-component cements for construction applications, and thereby reducing the need for energy intensive cement clinker production. Richard, over to you.
Thanks for the opportunity to showcase the exciting developments in low-carbon cements and concretes. I'm Dr. Richard Lees from the Mineral Products Association. The UK concrete and cement industry takes its environmental responsibilities seriously. In fact, the industry is decarbonising faster than the UK as a whole, where the UK as a whole has reduced its emissions by 43% since 1990, and the UK concrete and cement industry by 53% on the same measure. This means that concrete and cement are around 1.5% of the total UK territorial emissions, which is 5 times lower than the global average. But we can't rest on this early action. Last year, we published a roadmap that outlines how 1.5% becomes zero and how we can contribute to other sectors lowering their environmental impact. No net zero journey can be delivered by industry alone. All actors, both supply chain and policymakers, need to play their role. The UK government has made some initial but important steps. The industrial decarbonisation, net zero and other strategies have brought with them government funding for innovation projects, and these are helping to deliver on the industry roadmap. MPA and our members are working together on collaborative innovations where the results are shared across the industry to maximise the environmental and business benefit. The low carbon multi-component cement project is one of our projects that will make significant contribution to the 12% reduction in emissions associated with the low carbon products lever of our 2050 roadmap. MPA is the project lead in the project titled Low Carbon Multi-Component Cements for UK Concrete Applications. MPA provided technical expertise and design of the new cements. Hansen Cement carried out the manufacture and homogenization of the cement powders and tested the cements for conformity. Building Research Establishment tested the cements in concrete, and Forterra Building Products carried out the design and manufacture of precast concrete test panels for demonstration. And the demonstration photo of the 8 panels with 8 cements at a HS2 site with an aggressive clay backfill material for long-term durability test. The Venn diagram illustrates the concept for the new cements in this project. In the UK, cement formulations currently consist of 2 main components. That's clinker, the energy-intensive product from a rotary cement kiln, and either fly ash or GGBS or limestone powder. In this project, MPA and industry experts developed 22 new multi-component cement compositions based on 3 main components. That's clinker plus limestone plus fly ash or GGBS. Using less clinker provides an opportunity to improve energy efficiency and to reduce embodied carbon. In a 2-year program, extensive durability testing was completed on concretes containing the new cements, which investigated resistance to carbonation, chlorides, sulfates, freezing and thawing, and alkali silica reaction. The project successfully demonstrated that new cements require less fly ash or GGBS to achieve performance compared to reference cements. Currently, 79% of the UK cement market sales is CEM 1 type cement, with a total market of 10 million tonnes. Of the cements in this project, 1 has a CO2 profile 60% lower than the current market leader cement CEM 1, a massive CO2 saving which equates to a 65% energy saving too. If fully deployed, this results in a reduction in direct emissions from cement production of over 4 million tonnes of CO2 every year. That's a huge leap in our decarbonisation journey. And on completion of the test programme, we need adoption and deployment. MPA's recommendations have been put forward to the British Standards Institution to include the new cement in the UK National UK Concrete Application Standard to help designers, specifiers, contractors and the wider construction sector to reduce emissions related to the use of concrete. I'm sure you'll agree that the IEEA funding has delivered real benefit here that will be experienced for generations to come in the low carbon built environment. Thank you.
Next, we will hear from Robert Manning at Evergreen Water Solutions, describing their mechanical dewatering process for wastewater treatment, which replaces energy-intensive centrifugal separation systems. So the project was demonstrated at the United Utilities Davy Home site.
This is Robert Mannion. I'm from Evergreen Water Solutions, and I'm here to talk about the volute disc press, which we worked on with United Utilities at Davy Hume for the last 12 months. I have my colleague Mino here from AMCO Europe, who's going to give you a little bit of an overview about the technology, how it works, and talk to you a little about the potential energy savings that the technology would have in the UK water industry and also in the industrial sector for wastewater treatment. Mino, can you just tell us a little bit how the volute disc press works? And we also have a model here to show you a scalable model that we can discuss also. Go ahead, Milo.
Welcome. Technology of volute has been introduced 30 years ago, so it's definitely not something new. It was developed in Japan, and right now we develop and produce this special screw presses in Prague, in the Czech Republic. Maybe the best way how to introduce the volute screw press is to compare it with the traditional screw press.
Yes, okay.
In traditional screw press, what usually you have a cylinder with the screw inside, and for filtering system, you are using some kind of mesh filter. In our case, we are not using the mesh, but we are using a combination of fixed and moving rings.
Okay.
Why we do that? What's the benefit of it? The benefit is once the screw is flying inside the cylinder, it is moving those loose or moving rings up and down. So actually they are consistently in the move, which creates a kind of very simple, beautiful self-cleaning principle.
Oh, wow. Okay.
Why we need that?
Wow.
We can save a lot of money for rinsing of water, cleaning the surface of the cylinder. Pressure from the tap water,
Okay.
1-2 bar is enough for the system.
And how much energy does this use, Milo?
Compared to centrifuge, I think this is the main, probably I would say, competitor when it comes to energy savings, when you can really show the benefit out of it. I think it's worth it to mention the long-term pilot test you did in Davyhulme, comparing the full size of the machine to the current installation with the centrifuges.
Okay. So just to give you a recap, we've done a 12-month full-scale trial with the volute on Davyhulme, which is a plant that has 91,000 tons of biosolids per year. And we got the opportunity through the Carbon Trust to demonstrate this through a containerized solution and to operate it in conjunction with United Utilities to demonstrate an energy saving. The energy saving target that we had set ourselves was a 70% energy saving, and we did this. We were able to achieve over 84% energy saving on the operation of the volute compared to the centrifuge on site. Milo, can you explain to the audience why we were able to achieve those massive results in energy saving?
Yeah, it's quite easy to explain. If we can move to this demo, this actually demonstrates how the cylinder of the volute looks like. You can see that we have a sludge inlet when flow-related sludge goes in. Then we actually divide the cylinder into two sections. The first one, as we call it, thickening zone. This is the zone when there is no much pressure applied on the sludge. And what we allow sludge to do is to escape easily from the cylinder. On the second part of the cylinder, as we call the watering zone, we apply already more pressure on the sludge in order to achieve a targeted dryness of the sludge cake. As you can see, the motor and the gearbox are all connected in one piece. For long maintenance, actually we can call it kind of maintenance-free solution. The operation speed of the volute, we are talking about 2 RPM, which was exactly the case in the Davyhulme. And the power consumption, as Robert already indicated, per 1 ton dry solid processed, we are talking about 23 kilowatts in case of a centrifuge and 4 kilowatts in case of volute. So there is a dramatic reduction of the power consumption of the technology. And fortunately, I have to say, many clients and operators are now focusing and checking their technology, how much carbon reduction, CO2 emission reduction they can implement into their system. So volute definitely brings this benefit when it comes to power consumption.
So thanks very much, Milo, for explaining the technology. As you can see, the volute is a very simplistic process and very easy for operators to operate and maintain. This Carbon Trust have facilitated us to do full-scale trials with this technology. It's been the first opportunity for us to test at full scale and have direct comparisons between centrifuge and the volute disc press. I hope you've enjoyed this presentation and thank you for watching. Bye for now.
Bye-bye.
We will hear now from Simon Branch at Prisma. The Prisma have developed a new application for liquid air energy storage, in which liquid air is efficiently generated, stored, and then released to provide compressed air to an industrial site.
Yeah, Air compressors are responsible for 10% of all industrial electricity use. This equates to 3.5 megatons of CO2 emissions in the UK alone. Prisma is a liquid air battery which will transform the way industry consumes energy. Hi, I'm Simon Branch and I'm the CEO of Innovatium Group Limited. Innovatium are developers of climate technologies, inventing processes to improve energy efficiency. Prisma is a world first, a liquid air battery that stores energy in a liquid air form. Our industrial partner is Aggregate Industries, a major force in construction. Our academic partner is Birmingham University, one of UK's centres of excellence for energy storage. Air compressors consume energy inefficiently in immense peaks and troughs to supply a plant's variable demand. This creates massive potential for Prisma to improve energy efficiency. Prisma is being factory tested at Wessington Cryogenics in Sunderland prior to demonstration at Aggregate Industries Cement Works in Staffordshire early December. The concept is simple. Prisma liquid air battery combines efficient compressed air production with enhanced energy storage. Prisma's new technology reduces energy consumption behind the meter by smoothing out the peaks and troughs of compressed air production. This reduces the cost and the carbon footprint. The heart of the Prisma system is our advanced thermal storage technology. It charges using cheaper off-peak electricity. The Prisma system boosts the pressure of the client's existing air supply to charge the unique liquefaction and storage vessel. This holds an amount of energy 150 times greater than compressed air in the form of liquid air. The cold energy it produces is stored for reuse later on in the discharge cycle. This air can then be discharged as high quality, clean, dry air on demand. This enables vastly increased efficiency in otherwise optimized air systems and promotes increased renewable generation through grid stabilization services. Energy storage of this type and use case does not currently exist. Prisma represents a transformative step change in the way industry consumes energy. There are no alternative technologies that provide the same energy efficient storage. The Prisma project will result in a saving of 1,400 megawatt hours or 600 tonnes of CO2 emissions per annum for this site. We anticipate a further five-fold saving across Aggregate Industries UK operations. In addition to these cost savings realised in energy efficiency, there are also significant commercial returns available from energy storage services to the grid. Prisma is significantly cheaper than existing energy storage options with an ROI of less than 2 years. Prisma's mechanical design is reliable and easy to maintain, able to operate at high cycling frequencies and has a lifespan in excess of 25 years. Prisma can provide users with up to 40% energy savings and hours of energy storage while actually making carbon footprint reductions synonymous with cost reduction. Here is Kathleen McCarthy of Aggregate Industries.
Hi, I'm Kirsty McCarthy and I'm the Sustainability Director for Aggregate Industries. Aggregate Industries is one of the UK's leading construction material suppliers. We have over 200 sites and around 3,700 employees. We produce and supply a range of construction materials, including aggregates, asphalt, ready-mix concrete, cement and precast concrete products. We also import and supply construction materials, we export some aggregates and carry out national road surfacing and contracting services. Sustainability is at the heart of our business, and we are committed to innovating and be the leading supplier of green construction materials in the UK. But in order to do this, we need to tackle our energy consumption, which makes up a significant part of our carbon footprint. 14% of our energy is electricity, and we are committed to accelerating our journey to net zero and achieving it before 2050. We are really excited to be part of this project, which enables us to reduce our energy consumption at source at one of our main sites, which is the cement works in Coulden. Collaboration and innovation projects for us is key to enabling us to transition to a net zero economy. And we are really excited about this project and the deployment of this new and innovative technology to our cement works.
Manufacturers are seeking credible climate technologies with a strong commercial return. We seek to engage with industry leaders who are early adopters of energy efficiency technology. This technology is easily transferable into other industries besides aggregates and cement, especially pharmaceuticals, food and beverage, automotive, chemicals, paper and textiles, and most other industries using compressed air. The second phase of the development of Prisma will be a production-ready 300 kilowatt-hour modular system. Future development will include an electrical power output module, opening up the wider storage market and providing a strong alternative to industrial battery storage, no matter the end use. Prisma will be available through purchase and lease agreements. Thank you for your attention.
We're coming now to the last case study of today. We will hear from Spirax Sarco sharing insights about their control of total dissolved solids in steam boilers that can avoid poor quality steam scaling and excessive boiler water blowdown.
Hi, I am Michael. I'll be taking you on the first section of this presentation, and Julian will be taking you on the remainder of the sections. We are absolutely delighted to present to you today the TDS Control System project. It is a collaboration between Spirax Sarco Limited, Bakkavor Food Wigan, and the University of Nottingham. Water in steam boilers generally contain impurities and dissolved solids, which over time will accumulate and can become problematic for the boiler, affecting the efficient and safe operation of these boilers. Boiler blowdown is typically used to discharge boiler water in a bid to manage these TDS levels. This project aims to trial an innovative step change in TDS control systems, minimizing the boiler blowdown by up to 80% and thereby saving hot heat and energy, which would have otherwise been lost in the blowdown. This trial is being carried out on a 2.5-ton boiler at Bakkavor Wigan. The TDS control system is based primarily around a novel and step change in TDS sensing using electromagnetic sensing technologies. It's over the testing period shown exceptional sensitivity to TDS levels, and it is relatively immune to scale deposition, which is the Achilles heel of existing TDS sensors, which renders them unreliable. The journey so far has been very exciting and challenging. We started this project in 2019, developing a system of monitoring and benchmarking the energy performance of the boiler at Bakkavor Wigan. We then proceeded to designing and developing an industrial prototype of the TDS system. Between 2020 and 2001, we've had and experienced a number of disruptions due to COVID-19 related delays, but we have now successfully installed and commissioned the system. We are now in the trial phase, and we should be completing that phase in the coming weeks.
The projected impacts for that technology could be really significant. Based on our current extrapolation from in-house testing, we estimate up to 5% energy saving for a gas boiler. Also, the calibration frequency will be reduced, so we'll save some time on calibration. On top of that, there's also an 8% feed water reduction that we envisage that will save a lot of water and chemicals. So overall, we estimate that the total carbon emission reduction will be up to 10%. From an industrial perspective, the technology can bring a world of benefits to the boiler management. It will maintain the highest boiler efficiency possible while reducing capital and labor costs by minimizing the maintenance, as we said, and overall save fuel, water, and chemicals. First, we are looking forward to finishing the demonstration at Bakkavor Wigan and extend this to additional boilers on site. Once that pilot phase is validated, we are projecting to deploy that across the whole Backable group. Thank you very much.
Great, and with that, we have now heard from all our IEEA Phase 1 and 2 case studies. Please remember, in addition to the 7 projects we've seen today, we have also presented 7 other case studies already in yesterday's session, which you will be able all to access online on demand. And if hearing now from these IEEA projects has inspired you and you want to know more about how to get involved with the IEEA, then make sure to stay online, as next you will be hearing from my colleagues about the next phase of the IEEA. Thank you very much.